Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 2 until 3 in the afternoon, and we are in our 5th week of our 9-week course. So a reminder that the support questions in your IEL booklet, the ones with the little pencil icon, are not for marking. You decide which ones and how many to do depending on your needs. If you are understanding a concept, feel free to skip questions. You don't have to do them just because they are there. Do whatever is best for you. The answers are at the back, and you can check your work and make sure that you are on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions, showing all your work, your steps, and your thinking. This way I can understand what it is that you understand and help you if you need more support. So how do you actually submit the work? There's 3 methods. The first is to scan your work and send it electronically. You can scan your completed work using a device. If you have an Apple device, the Notes app comes along with it. And if you have a an Android device, the Google Drive app has a scan function. These are both free apps that come with these devices and are also easy to download if you need to. And then you're able to scan. If you're not sure how to do this and you need some support, either ask for help or check out my YouTube channel where I have tech tutorials which walk you through how to scan using these devices and these applications. Then once you have it scanned, you can send it to me through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. Then the third method is to hand in your work to your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded, and I upload them to YouTube shortly after airing, and then share them on my Facebook. So it's really easy for you to access. They're all under a playlist called MBF3C. And then there is also on my channel short videos that explain common errors and confusing concepts that can be a good place to go if you're struggling with something, making the same mistake over and over again, and just need a little extra help. Checking out there is a good place to start if you're trying to get some more support. Math is a really visual subject, so I strongly encourage you to access the videos. The audio isn't going to give you the full experience. Really seeing how I organize my information and what it is that I'm doing, the connections I'm making to the visuals is really going to give you a full understanding. So joining me live with the Zoom, even if you don't want to talk to me, that's fine. You don't have to ask me questions, just watching is great. Or watching the YouTube channel is another great option. If that doesn't work for you, let me know, and I'm happy to send you a copy of the recordings so that you can get set up for success. If you have any questions, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. You can call me on the office phone at 807-737-1488, extension 2209, or you can call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. All right, we're now looking at lesson 12 today, where we're looking at the law of sine. So let's dive in. This is something that's pretty new and can be a little bit tricky, but we can do it together. So our learning goals are that at the end of this lesson, you will be able to interpret information, then draw and label diagrams specifically to triangles and specifically to triangles and trigonometry. And you will understand how to use the sine law to find unknown sides and angles. We will complete all of this today in this one lesson. Our success criteria are that you can label triangle angles and sides, you could explain when to use the sine law, and you can solve for unknown sides and angles using the sine law. So when we'll use this in real life? Well, we are building brain muscle is what you can sort of think of it as. The same way that if you want to build physical muscle in your body, doing repetitive action is how you strengthen those muscles. Most of us probably do not need to be able to lift barbells on a day-to-day basis, but the practice of lifting barbells strengthens our arms, and that repetitive movement means that we build that muscle. So the same way with doing this kind of problem solving, these kind of critical thinking activities, build our brain muscle and set our brains up for tackling problems in our lives. All right, but let's first activate a brain with some mental math. I'm not a believer of Mad Math minutes. They create stress and anxiety in more students than not, and they focus on memorization and speed, which are not really that important when it comes to deep mathematical understanding. So we don't focus on that in my class. Instead, we work on developing strategies that make us confident and comfortable using numbers. So our question today is 273 times 69. Now, multiplication with this kind of number, most students would just sort of stack them and multiply them, and having to remember about placeholder zeros and moving things along and adding and subtract. When do you do what? And carrying numbers, and can get really quite confusing. And what we're going to do today is another way to multiply. You can do this in your head. It's a lot of information to hold in your head, or it's another way to write it down that might be a little bit easier. So this is called partial products, or if you're looking it up online, it could be called the box method of multiplication. And what we're going to do is I'm going to break up my numbers in their place value. So 273 becomes 200 plus 70 plus 3. And I've written that across the top of my box. And then along the side of my box, I'm going to write 69 by writing 60 plus 9. Then everywhere I have a plus sign, I'm going to draw a line to organize, again, my information. And now we're going to use the area model of multiplying. So we're going to think about, obviously, my box is not to scale, and that does not matter. We're just organizing it. So we're going to think of what 200 times 60. Well, 2 times 6 is 12. And then because I know that I have those 3 zeros, that's going to make it to be 12,000 in terms of how in place value, how I would move it over. Then 60 times 70, well, again, 6 times 7 is 42. So 60 times 7 would be 420. And then 60 times 70 is going to be 4,200. 60 times 3 is going to be 180. Then I go 20 times 9. 2 times 9 is 18. So sorry, not 20, 200 times 9. So 200 times 9 is going to be a 1,800. 70 times 9, 7 times 9 is 63. So 70 times 9 is going to be 630. 3 times 9 is 27. So now I've made sure that every single part got multiplied by every single part. And now I just need to add them up. And I can do that. I can list them, or I can add them up in ways that seem friendly. I can maybe add the things that are with 3 digits. So 630 plus 180. Well, 30 plus 80 is going to be 110. So plus another 100, 210 plus 600 is going to be 810. 27, I don't have any other 2 digits, so I'm not going to write anything, nothing to add there. And then 4,200 plus 1,800. Well, 800 plus 200 is 1,000. So that's going to be 6,000 in total. And then I have 12,000. So 12,000 plus 6,000 is 18,000. 800, there's no other hundreds. Then 10 plus 27 is 37. So this multiplies to be 18,837. Again, this is not a beautiful way to write it down, but it's a way to understand what's going on and just do the calculation correctly. So it is not the most elegant, it's not the most beautiful. Writing out the standard algorithm is you're doing the same math, but you're just writing it down in a different way. But our goal isn't at this moment isn't to have the most beautifully written thing down. It's to make sure that we're understanding and have different tools to do multiplication. So this is how you can do this kind of stuff with really big numbers too. You're not limited by the size of the number. All right, mine's on. What prior learning do we need to know for today's lesson? So I wanted to go over again another way of labeling triangles. With primary trigonometry, we talked about labeling triangles, but here this is just the general way that we label the parts of a triangle. So the vertices, which are the corners of a triangle, we label with capital letters. That is the standard agreed upon way of doing it in the math world. So here in this triangle, I have D, E, and F are my 3 vertices. And so they are labeled with capital letters. Then my sides are labeled with lowercase letters. So again, I have D, E, and F, but this time as lowercase, small letters, and those are indicating my side lengths. The other key information is that the opposite vertices and sides are matching letters. So capital D is across from little d, capital E is across from little e, and capital F is across from little f. So this is really important because when we are doing our sine law today and our cosine law in lesson 13, the way that we know which information to go in what place is super important because we've labeled our triangles correctly using this practice of capital letters as the vertices, small letters as the sides, and the sides being and them corresponding opposite each other. Super important. Seems ridiculous, but super important. Okay, so then let's dive in with our new concepts today. So the Sine Law is around us in terms of ways that information is measured in various places. So I have some examples here in terms of water, a water tower and a ranger's tower, and a fire and forest fire. So rangers use the information using tools to figure out how far distances are to figure out where a forest fire is. And so being able to track and how far it is away from the tools that they need. The same way in terms of architecture and engineering, here I have an image of a chandelier being hung with 2 ropes from the ceiling, and that placement based on knowing where that placement's going to be based on the length of the ropes and the angles that the things are hung at. And then also in terms of airplanes flying and velocity and wind, part of how airplanes end up where they are wanting to go and are staying on course in taking into account wind speed and force. This, the Sine Law is in the computers that are doing this. So you're not necessarily, pilots aren't necessarily doing this math on the fly, but the engineering and computer programming systems that are in place to make sure that planes go in the right place would use this kind of math. Those are just a few examples. All right, I'm going to go through a part that is conceptual understanding of why the Sine Law works. This is not in your IEL booklet, and you do not have to know it. I'm not going to test you on it. This is not going to be part of an assignment, but if understanding how things work helps you understand how to actually do something, then this part is for you. It is a little bit tricky. If this just confuses you and you are fine with just following the rule without knowing where it came from, it is completely fine to skip over this part and not spend time here if this is just confusing you. That is okay. But I know that some students really need to understand the why in order to be able to actually do the math. So I wanted to include that in this section. When we're back to what's just using the formula and plugging things in, I'll indicate that so that you can jump to that part if that's what works for you. All right, so why does a Sine Law make sense? And we don't even know what the Sine Law is yet, but that's okay. We're trying to figure out why the pieces that go into this rule being useful. So we have a triangle. We're going to label the vertices A, B, and C, so capital A, B, and C, which means that our sides are, the corresponding sides are labeled A, B, and C. What I'm going to do is I'm going to cut my triangle. Oh, something else to note about my triangle. My triangle is not a right angle triangle. It can be any kind of triangle. It does not have to be a right angle triangle. So I'm going to cut my triangle into two smaller triangles by doing what is called dropping a perpendicular from my vertice C. And that means that it's perpendicular to my line AB, to my line C. So now I have two, my big triangle is made up of two little right angle triangles. And this length from C, my vertex C to my side C, we're going to call it H for my height. We don't know how long it is, but we're just going to call it H. So now we have a triangle. We have two triangles that we're going to be using to make the law sense. So we're going to just first look at our bigger triangle, which is called, we're going to call ACD. So where that point where the perpendicular hit my line C, we're going to call that point D because that's now a corner of my triangle. And remember, this is a right angle triangle. So here looking at our, if we look at our reference angle A, then H is our hypotenuse and Y is our, sorry, and B is our, I don't know what I just said. I was just saying words. So H is our opposite and B is our hypotenuse. I'm not sure if that's what I said before. Sorry, my brain just fizzed out. So referring back to our previous lesson, this is sine of A is equal to opposite over hypotenuse. So that means that sine of A is equal to H over B. So H, we want to figure out how high this was, is equal to B times sine of A. We could rearrange it any way we wanted to figure out one of these variables, but we're going to just, for this sake, we're going to say that this height is equal to the side B times the sine of A. Now, if we look at our smaller triangle, the other half of our big, huge triangle, so triangle BCD, we still have that height hypotenuse, sorry, our height H is still one of our sides, the same H. So now looking at a reference angle B, then H is the opposite and A now is the hypotenuse. So sine of B is equal to opposite over hypotenuse, still by the definition. So sine B is equal to H over A. So H is equal to sine sine B times A. But, which I can also write as H equals A times sine B. So if we look back at our big, huge triangle, remember our H is the height and it's just a line that we have in the middle of our triangle, and it is the same line. So our H is equal to the same thing. So both of our things were equal to H, which means both of our things are equal to each other. So B times sine A is equal to A times sine B, which we then can rearrange and organize if we divide both sides by A. And the A cancels off on the one side. And then we divide both sides by B. Then the B cancels off on the other side. And we're left with sine A divided by A is equal to sine B divided by B. So we now have this relationship between the sine of an angle and the opposite side, and the sine of another angle and the corresponding opposite side. So we know that those ratios are the same. We don't need to use the trigonometry. We don't need to use we don't need to use the primary trigonometry. Like we don't need to use the opposite over hypotenuse anymore. We don't need to have a line in the middle of our triangle. We just know that no matter what our triangle is, this relationship is true. So this same process is true if we use any vertex to cut through in our triangle. So if instead of cutting from C down, we cut from B, it's still going to be true. We'll still have two little triangles that then we could do the same thing for. So we would get sine A divided by A is equal to sine C divided by C. Or if we dropped it from A down to side A, we would have two triangles and we would be able to figure out that again, sine C divided by little c is equal to sine B divided by little b. So again, you can see why it's really important that you are labeling your triangles properly with your capitals and your small letters to make this make sense. So this is all the same. So as you can see again, these are all equal to each other. Sine A divided by A is equal to sine C divided by C, which is equal to sine B divided by B. And that is what the sine law is. We usually rearrange it to be in alphabetical order, where we say sine A divided by A is equal to sine B divided by B, which is equal to sine C divided by C. And that is the sine law, which is what we're going to be using. And that's how you understand how the sine law actually comes into play. Again, this is not something you'll be tested on, but just understanding where it comes from, that really helps for some students. So now let's look at the sine law formula, and this is what everyone needs to know and practice if you are, in order to complete this lesson, this is the part that you actually need to not just understand, but compute the lesson. So this is on page 21 of your IL booklet, and this is recognizing when to use the sine law. So we have tools for using that we used in our previous lesson, but why are we introducing a new type of rule? So this works for any kind of triangle. It does not have to be a right angle triangle, like I mentioned before. You need to know 2 angle measures and 1 side measure. Or, so if you have a triangle and you know 2 of the angles and 1 of the sides, you can use the sine law. It doesn't matter which side it is that you know and which side you don't know, as long as you know 2 of your angles. Because we remember that the angles of a triangle are equal to 180. So if you know 2 of your angles, you can always figure out your 3rd angle, and then you can use that to figure out your 2 sides. So that's why it doesn't matter which sides you know. You can always figure it out if you know 2 angles. Or the other situation that it might be is if you have an angle, you know 1 angle and 2 side measures, as long as one of the sides is opposite the given angle. So here we have in a picture, I have a triangle JKL, and I know angle K, and I know side K, and I know side J, and I'm looking for angle J. Well, because I know the side opposite the angle K, then I can use the sine law. I know those, I need the two corresponding ones, and I can't figure out my third angle because I only know one angle. So that's why when we know two angles, we can always figure out the third angle, but in this case, we can't. So if we look at it differently on my same triangle, JKL, and if instead of knowing my side K, I knew my side L, well, now we can see that I don't know any angle that corresponds with a side. And so I wouldn't be able to figure out that ratio because I don't have enough information. This knowing we have to have that corresponding pair in some way. So that it does not work. So that's really super important when you're using sine law. You have to either have two angles and a side or one angle and two sides, as long as one of the sides is across from the angle that you know. Okay, so let's actually do a question and see what this is all, how this actually works. So using the sine law to find an angle. So I have a triangle ABC with angle A is 72 degrees. That's what I'm starting with. So that means that across from angle A is side A, which is 18 centimeters. I'm looking for angle C. I have a question mark there, and across from angle C is side C, and that is 15 centimeters. So because I have one angle, two sides, and a side that corresponds with the angle that I know, I can use the sine law. So I like to write down the whole sine law to start with. So sine A is equal to sine A divided by A is equal to sine B divided by B is equal to sine C divided by C. And then I know that I only need sine A divided by A is equal to sine C divided by C. So you don't have to write down all three. You could just write down sine A divided by A equals sine C divided by C. That's fine. So then I plug in the information that I know. So now I have sine 72 divided by 18 is equal to sine C divided by 15. Again, this is why it's super important to know your proper vertices and side letters in order to put the numbers in the right places. So then in order to isolate for sine C, I'm going to multiply both sides by 15 to isolate. So I cancel out the 15 on one side. So I have 15 times sine 72 divided by 18 is now equal to sine C. So then I can do that calculation. So I do 15 times sine 72 divided by 18, the same way we've done it in primary trigonometry, the same buttons that we're pressing. So that's equal to 0.7925. Again, using it, if you're writing it down, at least 4 decimal places, 4 or 5 is ideal, equals sine C. So to figure out what angle C is, we need to do sine inverse of 0.7925 equals sine inverse of sine C. Remember this, the sine inverse of sine C, cancel that off and leaves us only with angle C, which gives us angle C is equal to 52.4 degrees. So remember, whenever we're doing primary trigonometry, our calculator must be in degrees. This is important, otherwise you won't get anything that makes any sense. And that's how we find, those are the steps in place of how to figure out what an angle is using the sine law. All right, so now we're going to do using the sine law to find a side. And we have two methods that we can use. So this is going to be the first method. So we have a triangle ABC, where we have, this time we have two angles and we're looking for a side. So we have angle B, which is 39, which is side B is what we're looking for and is unknown. And then we have angle A, which is 65, and across from that is side 30, which is 30, which is side A. So we have two angles and a side that we know, and we're looking for a side. So we can use a sine law, and we're going to this time do sine A divided by A is equal to sine B divided by B. So again, we fill in the numbers that we know. So sine 65 divided by 30 is equal to sine 39 divided by B. And we're trying to isolate for B. So that means we're going to multiply, right now B is in our denominator, so we're going to multiply both sides by B in order to cancel it off. So we end up with B equals, sorry, B sine 65 divided by 30 is equal to sine 39. And now we're going to multiply both sides by 30 in order to cancel off the we're divided by 30. And then we're going to cancel off the sine 65 in order to isolate for B. So we end up with B equals 30 times sine 39 divided by sine 65. So once we do that, remembering that our calculator's in degrees, we end up with B is equal to 20.8 meters. And that's the number that we end up with. So that's one way of finding the sine law. Basic, you're doing the same thing that you did before. You just have to do a little bit of algebra and rearranging, which can be easy to make mistakes on. So what I want to stop and think about is this idea of flipping proportions. So this is just a little sort of aside to help us understand something else that I'm going to explain in a minute. So I want us to look at these proportions, which are these ratios that equal each other, right? So 1/2 is equal to 3/6, which is equal to 5/10, which is equal to 12/24, right? Those are all equal to a half. They're the same thing, just explained in different ways. This is true, right? Hopefully. If I flip them, it is also true that 2/1 is equal to 6/3 is equal to 10/5 is equal to 24/12. Those all equal to be 2. This is the same value. If I flip all of them, it is the same information. So doesn't matter which way, if all I'm caring about is the ratio, is the proportion, the comparison of the proportion, it doesn't matter if which order I write them in, both of them are true. So how we apply this is that sine A over A is equal to sine B over B is equal to sine C over C. We know that is true. So if we flip that, we know that A over sine A is equal to B over sine B is equal to C over sine C. This is also true. It's the same law. We've just flipped it upside down and it's still true. The relationship is still true. So we can use that to find the side in a little bit using less algebra. So this is a second method for finding the side using the sine law. Again, you will get the same answer, but we will have to do less algebra, which might be better for some folks. So we have our same triangle. Angle B is across, which is 39, which is across from side B. Angle A is 65, which is across from side A, which is 30 meters. So this time we're going to use A over sine A equals B over sine B equals C over sine C, which really all we need is A over sine A is equal to B over sine B. We're going to put in everything that we know. 30 over sine 65 is equal to B over sine 39. We're going to multiply both sides by sine 39 in order to isolate for B. So that means that it cancels off on the one side, which now means that we're left with 30 times sine 39 divided by sine 65 is equal to B. So this, we don't have to do any more rearranging. We have it just already all by itself. So B is equal to 20.8 meters, which is exactly the same thing that we got the other way, but I had to do less rearranging, which makes our lives a little bit easier. Again, calculator must be in degrees. So then you're going to ask me, okay, great. You give me two versions of the same formula. How do I know which one to use and when it's going to be useful? How is it going to make my life easier opposed to you've just made my life more complicated? So Always, you can use either formula anytime the sine law is required. Anytime it makes sense to use a sine law, you can use either one. The only reason that we have two is that one is easier to use than the other in certain situations, but you can always use either one. So if it makes sense for you to use only one every single time and that's working for you, that is totally fine. But if you want to do less algebra, if doing algebra is where you often make mistakes and it's easier for you to have two options to do less algebra, then when you are solving for angles, you're going to use sine A over A equals sine B over B, which is equal to sine C over C. The angles are on the top. The sine capital A is on the top, so you're going to be solving for angles. If you're solving for sides, you're going to use little a over sine A equals little b over sine B equals little c over sine C. The side length, the little letters, are on the top here. And that's why it's easier and you don't have to do as much algebra because you already have what you want on the top. So that's how you can remember it if that makes your life easier. As always, because I just have to keep reminding you, your calculator must be in degrees. Okay, so now you can do the support questions on page 24, questions 1 through 9. That is that's going to cover this lesson. But let's do some practice questions together so that we have some practice, because we all know practice helps us to improve. Okay, number 1. Solve for the unknown. So often these questions will just say solve for the unknown, and you have to look at the triangle in order for it to make sense. So really, if you don't have a triangle, you need to draw it. But if a question's like this, where it just says solve for the unknown, they're going to give you a triangle. So we have a triangle ABC with angle A being 47. So the side across from that is going to be side A, which is 4. And then here, our other angle that's referenced or indicated on our triangle is angle C. So that's our unknown. And the side across from that is side C, which is 5. So because we have one angle, but two sides with our known side is across from our known angle, then we're good to use the sine law. So because I'm finding the angle, I'm going to use the sine law that finds angles easier. So sine A over A is equal to sine C over C. So now I'm going to fill in what I know. Sine 47 divided by 4 is equal to sine C divided by 5. Then in order to cancel off this 5, I'm going to multiply both sides by 5. I've been using the dots. You can also use brackets. They're just different notation for multiplying. Sorry that I changed it up on you. So multiplying both sides by 5 means that my 5's cancel off. And I'm left with 5 times sine 47 divided by 4 equals sine C. So if you want to do it all in one step, you can. So if you're going to then do sine inverse of 5 times sine 47 divided by 4 equals sine inverse of sine C, that's fine. If you're not sure what I'm doing with the sine inverse, go back to lesson 11 and check that out, as will make where I put it in to make sense. So I'm going to put it all in once in my Desmos. As always, you can do it in more steps if you want to. I'd like to give you options in terms of what feels best for you. You do what is best for you. So we have sine inverse of 5 times sine 47 divided by 4 is equal to 66.1 degrees. So angle C is equal to 66.1 degrees. And that's how we solve for an angle. All right, so sometimes we're given a question like this, where it says, solve for the unknown. And it says in triangle DEF, solve for F, given angle D equals 60 degrees, angle F equals 39 degrees, and E equals 10 meters. So this is confusing because you don't have a picture. So you have to draw a picture, set yourself up for success, draw your picture. So this little symbol here, I write it as triangle. That's what it means. It tells me that we have a triangle. I don't care if your triangle is accurate. You do not need to use a protractor to get an accurate triangle. Just draw yourself a triangle. Label your sides. Again, it doesn't matter to me where your angles are labeled. This is why we're labeling it. It's okay if it's not perfect, or if it's not to scale, or if it's not ideal. That's all fine. Now that I've labeled my vertices, I'm going to label my sides so that I know which ones are which. And I'm going to go back to my question and see what do I know. So solve for F, that's what we're going to be looking for. Side F. Given angle D is equal to 66. So I'm going to put 66 on my triangle where D is. Angle F is 39 degrees. So I'm going to put 39 at angle F. And E is equal to 10 meters. So E equals 10. All right, so in the question, it didn't tell me what side D equals, and it didn't tell me what side or angle E equals. Okay. So can I use the sine law? I have two angles and a side. Well, if I have two angles, that means that I can always find the third angle, which is good because this time I don't know the angle across from, sorry, I don't know the side across from the angle that I do know. So that means that I need to figure out what my angle E is. So angle E is equal to 180 degrees because all triangles equal to 180 degrees. Take away 66, take away 39. So using our Desmos, if our brain is not on our side today to do mental math, totally reasonable. Take away 66, take away 39 is equal to 75. So angle E is equal to 75 degrees. So now I have an angle across from a side that I know, and I have an angle across from the side that I'm looking for. Great, I can use the sine law now. So that was little step one. Now step two, we're going to use the sine law. This time, because I'm looking for a side, I'm going to put it on the top. So I'm going to say side F is equal to sine F, sorry, F over sine F is equal to, sorry, my hand makes this right sometimes it doesn't, is equal to E over sine E. Now, I didn't put this in alphabetical order this time. I put in what I wanted to find first. That's totally fine. As long as your letters line up, that you have your corresponding letters, the same letter on the same side of the equal sign, it is okay. The order otherwise doesn't matter. Now I'm going to put in what I know and what I don't know. So F over sine 39 is equal to E over sine 75. Not E, I know what that is, 10. So F is equal to 10 over sine 75 times sine 39, because I multiplied both sides by 39. So F, sorry, not by 39, by sine 39, because multiplying it by 39 would be different. So 10 divided by sine 75 times sine 39 is equal to 6.5. So side F is equal to 6.5 meters. It's going to be the same unit that your other side is in. And that's how we find an unknown side. Number 3, explain why the below triangle cannot be used solving the sine law. So I have a triangle NML, or LMN, I guess, whatever. And I know all the sides. I know side M is 51. I know side L is 48. And I know side N is 62. But I don't know any angles. So the sine law requires that I know at least one angle. And I don't. So I can't use the sine law for this question. Is it a right triangle? Nope. So I can't use the primary trigonometry either. I don't have the tools yet for this triangle, but stay tuned for lesson 13 where we'll learn how to use it, what we can use to solve for it. Okay, a word problem. Let's look at this. Number 4, 2 guy wires, 27 meters and 15 meters in length are to be fastened to the top of a TV tower from 2 points B and C as shown. How far apart are points B and C? So I have a pole, and I'm going to have 2 guy wires, which are those wires that stick from a pole and stick it to the ground. So I have a wire that's going to point B, and that length is 27 meters. And I have a wire going to point C, and that is 15 meters. And I know that my angle between I know that at angle B is 32. So sometimes they just tell you on your diagram what your angle is. Great. So do I have enough information to figure this out? I know one angle, and I know a side across from that. And I want to know side A, but I do not know the angle at angle A, so I cannot figure out using the sine law in just one step. But I know the side C, so I could figure out angle C, and then if I have 2 angles, I can figure out what my third angle is. So I'm going to need to do this in a few steps. So first, I'm going to find angle C. So I'm looking for the angle. So I'm going to say sine C divided by C is equal to sine B divided by B. So sine C divided by 27 is equal to sine 32 divided by 15. So sine C is equal to sine 32 times 27 divided by 15. So angle C is equal to the sine inverse of sine 32 times 27 divided by 15. So calculator. Sine inverse of sine 32 times 27 divided by 15 is equal to 72.5. I'm just going to round that up to 73 because all of my other angles are just don't have any decimal points. Okay, so now for part 2, I'm going to figure out what angle A is equal to. So find angle A. So that's 180, take away 32, take away 73. So that is equal to 75. It's not always going to equal to 75. That's what's happened to us today. So angle A, this whole angle here is 75. And now we can figure out what side A is. Now we know because we figured out angle C, we could use either angle C or angle B to figure out what side A is going to be. I would strongly encourage you to use the part that's in the question. Because if you've made a mistake, then that's going to affect things. But so it's better to use what we know is true. So we are looking for a side. So I'm going to use A divided by sine A is equal to B divided by sine B. I'm going to fill in what I know. A over sine 75 is equal to 15 divided by sine 32. A is equal to 15 times sine 75 divided by sine 32. Sorry, I'm running out of space. It's a little bit messy. A is equal to, now I'm not writing down every single step. I know that it is best, and I encourage you to do that. But you don't have to. If what you're doing makes sense to you, that is fine. So we have found that our side length is 27. A is equal to 27 meters. So therefore, the distance from point B to C is 27 meters. There you go. Sorry, it's a little messy. That happens sometimes. That's why I've labeled it as much as I can. So then next, this question is asked, how tall is a tower? So figuring out how tall H is. We don't have time to do that right now. But if you think about it, this is a right angle triangle, right? So if it's a right angle triangle, you can use your primary trigonometric ratios. You don't have to use the sine law just because we're in a sine law unit. That's fine. You can use primary trig if it makes sense. The sine law will still work. You can use the sine law, but if you use primary trig, it'll be a little bit easier. All right, so let's consolidate what we've learned today quickly. Today in lesson 12, the sine law. So labeling our triangles is super important. We've seen the vertices are capital letters, the sides are lowercase letters, and opposites match each other. Using the sine law only when you either know two angles and a side, or when you know two sides and an angle that is opposite one of the sides, and that which formula of the sine law to use, that both versions work in all situations. But if you're looking for an angle, having the angle part on top is going to make your life easier. So sine A over A equals sine B over B equals sine C over C. And if you're looking for sides, having the side on the top makes your life easier. So A over sine A equals B over sine B equals C over sine C. So hopefully you are comfortable with your success criteria now, that you can label the triangle angles and sides. You can explain when to use the sine law, and you can solve unknown sides and angles using the sine law. If you have any questions, as always, please reach out and connect with me. I'm here to support you. This stuff is a bit abstract and a bit tricky, so please reach out and connect. Give me a call at the office at 807-737-1488, extension 2209, or call toll free at 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslatewahsa, or check out my channel at bslatewahsa on YouTube, where this lesson, as well as all of our other lessons, are posted up there in a playlist called MBF3C. Thank you so much for joining me today, and I hope you have a lovely day. Which